Welcome to video 2.6. Today we're going to talk about error and percent error. So error is defined as the difference between an experimental value and an accepted value. So mathematically, that basically just looks like the difference between experimental minus accepted equals error. One thing to remember is that error is always going to end up being positive, so you would have to take the absolute value of this. A couple of things to remember. Experimental value. This is what the student did. This is what you get in a lab. The accepted value, or the actual value, is provided by a teacher, by an instructor. It comes from scientific literature. So, when you are actually calculating error, the accepted value is going to be given to you. The experimental value is what you yourself came up with, or what the student in the question came up with. So, error is experimental minus accepted. Could I flip that around and do accepted minus experimental? Yes, because you're taking the absolute value. So error, when we're using it in percent error, you're going to take the absolute value. You can have, I misspoke earlier. You can have negative error, but basically that just tells you that which way it swung. So whether it swung towards you overshooting the accepted value or you undershooting the accepted value. Most of the time in chemistry, we are going to undershoot. So when we are calculating percent error, it expresses error as a percentage of the accepted value. So percent error is the error divided by the accepted value times 100. Since I know that error is the experimental minus the accepted, I can rewrite this as the error equation divided by accepted value times 100, and that is percent error. So right here we're going to calculate it. Right here it says a student determines the density of a sugar solution to be 1.57 grams per milliliter. The actual density of the solution is 1.59 grams per milliliter. What is the percent error? So the first thing I have to do is I know percent error is going to end up being experimental minus accepted, I take the absolute value of that, divided by accepted times 100. So when I look at the question, it tells me the student determined the density to be 1.57. Is that going to be the experimental or the accepted? Hopefully you said experimental. So experimental, I'm going to plug this in, is going to be 1.57. And the actual density of the solution is 1.59, so that's going to be my accepted value. So I'm going to plug that in to my 1.59. So when I end up taking the absolute value of that, I'm going to end up getting negative 0.02, but I take the absolute value. So I'm going to get 0.02 divided by 1.59 times 100, because I would like this to be a percent. So 0.02 divided by 1.59 times 100, it's going to give me a 1.26% error. That's a really good percent error. That would mean your grade would be a 98.74%, which is a pretty good percent correct. So when your percent error is that low, that's a very good thing. So if you look at this data, this is where student A got their average of data as their experimental value right here is 1.57. Right here, student B's experimental value is 1.59, and right here, student C's experimental value is 1.70. So what we're doing is those are the experimental values for each individual student, and we're going to compare that to the actual value. So the experimental value is what the student got, and the actual value is what was given by the data. So that is how to calculate error and percent error.